Thank you for having me. My name is Alvaro Videla. I'm from Uruguay, and I work as an engineer at fauna.com. It's a new database, a NoSQL database. Please visit the website so my manager knows I'm here. I wrote this article last year. It got over 100,000 visitors, basically explaining my story on how I got into programming. 10 years ago, I was basically selling food in the streets in the countryside of Uruguay. But about this talk, it's called Metaphors We Compute By, and you can read it on the ACM website, for example, and also on the communications of the ACM. So the year is 1980, 1 year earlier from me being born. And there is a book published called Metaphors We Live By. So you can tell already that the title of my talk is nothing original. It's just a copy of that thing. Because this work was so influential that after it came Metaphors We Socialize By, Metaphors We I don't know what by. So this work by Lakoff and Johnson, the idea was to study the brain because they were cognitive scientists. But you cannot literally go and open people's brains and see what's there inside. That's kind of illegal. It tends to be. So they say, OK, let's try to understand the brain by using a proxy, which is language. And they find out that metaphor isn't just a matter of poetry, like rhetorical flourish. Like metaphors, actually, they dictate the way we think, how we behave, how we perceive, and how our conceptual system is built. So to give you an example, which is the first from their book, they say argument is war. War is a metaphor in which we frame argument. I think this is kind of in line with the previous talk, why people have all these frameworks on the internet. Because if we think of argument as war, we will say things like, your claims are indefensible. He attacked every weak point in my argument. I demolished his argument. I never won an argument with him, or his criticisms were right on target. The point being, because of this framing of arguing as a war, we're literally trying to destroy the other person. And they ask, Lakoff in this book asks, like, what if argument will be dance? Which kind of metaphor will we be using? And then thinking about argument. Because if it's dance, we need to collaborate together to reach a common goal. And then maybe a metaphor will be, you shouldn't be stepping on my toes, or something like that. But it will be a more collaborative thing. But I can see your faces that you are still not convinced. And when people is not convinced, we talk about politics, right? And there was a really nice article from the BBC called How Metaphors Shape Women's Lives. But it talked about all this glass ceiling metaphor and whatnot, like how you are stopped from progressing at companies. But for me, even more interesting in that article was this research that was done where they grab a group of students and they tell them that there is a wild beast preying on the city. Like crime is a wild beast preying on the city. And to the other group, they tell them that virus is infecting the city. Both groups get the same data, the same statistics, and so on. They have a different framing metaphor. When people is asked, what are the solutions they propose, 75% of the beast students, they wanted to put people in jail and do very strong punishment. And the people in the virus case wanted to help the other, help them improve, progress, and so on. So when they ask them, like, why do you choose that kind of punishment, or why do you want to help people get better, and so on, they say, because the data says so. None of them realized they were primed with a particular metaphor. There is also a book from the 80s by Judy Weichmann. It's called Feminism Confronts Technology. And it's really good if you want to have a deep dive into a feminism point of view into technology. And it's like how the words hard and soft has been changing across the history of technology. Like, at some point, intellectual work wasn't considered interesting or whatever, so all the machos out there deemed this work soft. But suddenly we had computers, and we could dominate the world with computers, so all this macho mentality brought the hard word into programming with all these very aggressive metaphors, like you need to be coding 24/7, you need to be pushing for that release, and all this thing like about your stamina and so on. And she says, no matter how masculinity is defined, according to this ever-adaptable ideology, it always constructs women as ill-suited to technological pursuits. So language is also important, even in how we approach different groups if we want to make, for example, technology friendlier for women or friendly for other groups, like in Latin America, for example. So still not convinced. Human resource management. If you think with this metaphor, you will think that the same way you replace a hard drive on a server, you replace a programmer on your team. And there are many managers that think this way, but we need to understand that people are not resources. Like, we are not here, thanks. We bring more to the wheel than just a thing that can be replaced. We build interpersonal relationships. We organize things to happen in certain times and so on. I mean, we are very rich living beings, not just a resource that I can just replace. And finally, trigger warning about giving platform to racist people. There is a conference in the United States, I won't name them, that they like to have keynoters as like racist people. Last year, the keynoter was one that considered women to be inferior, and so on. When the community came against this conference, and they criticized them for having a racist person as a keynoter, they wrote a blog post. And this blog post was called Wrestling with Inclusion at whatever the name of that conf. And I wonder, wrestling, why do you need to wrestle with inclusion? What, can you just have a dialogue? What, can't you talk with people involved in these communities? No, they decided to wrestle. I'm gonna beat you down, right? But I guess you're here to talk about computers, right? So computers. Have you seen the movie Hidden Figures, where these astronauts from the States, the black women helped put an American in space? The Russians had done that already. They were doing calculation, they were doing computing by hand. So these women were called computers. But at some point, we had this very fast machine, electronic machine, that was doing what they were doing really fast. So how do we call those things that do what these people is already doing? Okay, automatic computers. The automatic word was dropped in history, and now we just call them computers. And why is this? Because metaphors, they enable understanding. When we don't know how to talk about something, we probably will use some sort of metaphor. I don't remember yesterday, if you give me a second, I was watching a talk here about this guy that made a simulator for colorblind people and things like that. And he said, additional screen real estate that you need to account for. So now there is real estate that we account for. This is completely metaphorical way of understanding what is going on, that just the screen is bigger and we need to do something with that bigger screen. But when I say that metaphors enable understanding, the typical metaphor is from Shakespeare that says, Juliet is like the sun. And we need to understand that metaphors aren't a one-to-one mapping between source domain and target domain. Metaphors, they just illuminate some areas so we understand what is meant, what Juliet means for Romeo in this case. Like, his life depends on her. He revolves around her all day, or his thoughts, or whatever. She's the light of his life. But we don't think Juliet gave me skin cancer, because we are smart enough to understand that metaphors aren't like one-to-one mapping, like Juliet isn't an atomic bomb walking around Italy, right? There is a book by a guy, I think, from either the Netherlands or Belgium, Peter Gardenfors, which is called The Geometry of Meaning, Semantics Based on Conceptual Spaces. Long story short, somebody got paid in Europe for doing geometrical research of language. These things in South America don't happen. We try to make sure that our cows make better meat, basically. Anyway, in that book, it's really interesting because he said that metaphorical mappings preserve the cognitive topology of the source domain in a way that is consistent with the inherent structure of the target domain. So, source, son, target, Juliet. Metaphors transfer information from one conceptual domain to another, and what is transferred is a pattern rather than domain-specific information. Juliet is not giving you cancer. And a metaphor can thus be used to identify a structure in a domain that would not have been discovered otherwise. So that is the power that metaphors bring us when we need to understand how the world actually works. And for me, I stole this animation from that link down there. This is what we are doing in a way with our brain with metaphors. We are doing like a graphic isomorphism problem that we solve constantly when we are able to apply a metaphor in a context that has nothing to do with it. This is how metaphors create new knowledge. But the problem with metaphors is that they also obscure understanding. Back in the 18th century, when they tried to create the telegraph, the metaphor was far writing, telegraph. And because of this metaphor, they were so tied to the metaphor that they really wanted to create a device that will kind of write remotely instead of having something like Morse code or whatever, because Morse code was not a thing. Thanks to Braille, and then Morse kind of saw that you could start encoding on language, our language, in a different code that is not the one that we use for speaking. Humanity realized, like, okay, we can transmit this that we talk in a different way. Before Morse code, before telegraph, we hadn't realized as a species or society that we could do these things with language. And Nicholas Carr, in this book, The Shadows, says that sometimes our tools do what we tell them to, but other times we adapt ourselves to our tools' requirements. And we need to be careful with this. Like, we are today adapted to having a phone and Twitter every day, let's say. Or back in the day when people invented this in Switzerland. I'm pretty sure it was not invented in Switzerland, but I live in Switzerland, I need to say these kind of things. So before, people didn't live by the second or by the minute. Whenever the church bell rang before they go into mass or whatever, they knew they had to gather at the town square or something like that. But it wasn't like they were clocking every single thing. And this is also, for example, I learned in London, like, this is why they know the exact locations when Jack the Ripper was doing things, because there are so many churches in London that they were hearing the bells. So after these many bells was that Jack the Ripper did something somewhere. So that was a way of tracking time back then. Today, we are totally adapted to having this super precise information. Back to the talk, metaphors are the tools of thought. So going back to the beginning of the talk, depending on the metaphors we use is how we understand the world around us, and also how we can understand code. There is a paper that nobody knows who wrote it because this was scanned from Donald Knuth archives, and not even Knuth knows who wrote this paper. And for me, it's like the best unknown paper. It's from back in the 60s, if I'm not mistaken. And they say, to program is to write to another programmer about our solution to a problem. So programming is, forget about the computer. The computer is just a tool. What we are doing with programs is communicating ideas, communicating solutions. And as they say also in the structure and interpretation of computer programs, programs must be written for people to read and only incidentally for machines to execute. And this is not something new. If we go back to the 1955, 54, David Wheeler from England, he invented the subroutine. Because that's what people do in England, right? They invent subroutines, they invent computers, stuff like that. But anyway, at the end of the paper, he says that there is no need for the subroutine when you have like assembler code. Because he says, the above remarks may be summarized by saying subroutines are very useful, although not absolutely necessary, and that the prime objectives to be borne in mind when constructing them are simplicity of use, correctness of code, and accuracy of description. All complexity should be, if possible, be buried out of sight. So yeah, there is no need for a subroutine. There is no need for refactoring code. But because we are communicating between people, we want to make sure they understand what we solve in that particular problem. And by the way, this woman here, this is a picture from a book that David Wheeler wrote, because he wrote the first programming book also, 1956 maybe or earlier. And this is the first programmer ever pictured in a programming book. So there you go with your machitos are the only ones that are programming. Anyway, and if you read the text below, look at the metaphors that back then were not metaphors. She has a library of tapes with where the subroutines are punched. So that thing there, that cabinet, was a library, an actual library of subroutines, which was like some paper thing that they would punch into the machine. I don't even know. So everything we talk is metaphorical in a way. You will see more later. But metaphors and code. In code, I say that types are the characters that tell the story of our programs. But for the Haskell people that is cheering in behind, chillax. Because I'm not talking about those types. It's types as in programming with abstract data types by Barbara Liskov. Barbara Liskov had to fight, you know, all this well actually that we have today on Twitter. If it was Twitter times, Barbara Liskov was full of those telling her that you don't need abstract data types, that abstraction was wrong. Because they were already in the post-war of GoTo, and they managed to move away from GoTo in 1964 and so on. So in 1974, she came, but we also can do abstraction. And people were all fighting against her ideas. But the problem is that if we don't have types, we just have operations on a stream of bytes. So let's talk about choosing the right data structure. We have a problem where we need, for example, to count or to keep somewhere all the people that came to JSConf EU. You can use an array that will work perfectly. You can just put everybody inside there, fine. But if you use a set, that metaphor that has a very specific meaning in mathematics is telling you that that bunch of whatever it is, in this case of users, those users have to be unique. So just by changing the data type, you are telling me a lot of information about how you solve your program. If you use a linked list, you are telling me you can traverse this in this way, but you cannot do inserts however you want. If you have a queue, you are telling me first in, first out. Stack, the reverse operation. Because a program explanatory power is the measure of its own elegance. If your program cannot explain what you're trying to do, not sure we satisfy the initial goal. And data structures, they have explanatory power that can give us cognitive leaps. For example, task scheduling. We want to be able to serve food based on the order in which people arrive at the counter and blah, and if their counter is full, maybe we need to bring another person to too boring. But if we start talking about queuing theory, if we understand this is a problem in queuing theory, not only we have a bunch of language to talk about that problem, there's a whole theory of queuing that was developed by Erlang back in the 30s, I think, for telecommunications, and we can base our analysis of the problem on actual mathematical theory. The same here. How do I get from here to Tegel Airport? Number one, don't take the bus, but you can try to guess and try many things, but at some point you will know you have a graph theory problem here. And with there, you have all the mathematics to solve this. And by the way, not only that map is not a map of the territory, if you have heard that sentence, the graph is a metaphor of that territory. And that graph is enabling you to do things with the territory, and also is forbidding you to do things with the territory. So that metaphor of the graph in graph theory and maps is what I was saying before. It has explanatory power, it has constraining powers. But I think the most interesting example comes from the replication, from database replication. They tried to build an algorithm to spread data using rumor mongering, basically. I'm a computer, I have some data, I say to this computer and this other computer, then this computer spread the rumor to other two computers, and so on. Like in a Latin American telenovela, the same way to spread rumors. So, this is the way we understand the world. The problem is, it's really easy to explain with this metaphor, but it's really hard to reason about the correctness of the algorithms. But they saw that this also mapped, watch the word mapped, to epidemics. And in Epidemics, there is a book which is the mathematical theory of epidemics from the 40s or 50s. So they can use all the math in that book to prove that their algorithm will spread the data to all the nodes doing replication because they understood another metaphor. The same way an epidemic goes through a population is how you can send data through a bunch of nodes. And is everything a metaphor then, like this is what you're trying to say? Yes. Actually, when I was watching this film, I heard her saying, metaphors be with you, because I was so into this thing. I said, like, did she really say metaphor be with you? Yes, she did. So everything is a metaphor. I don't believe you. I just read one slide because I don't have that much time, but this is distributed system literature. Whenever nodes need to agree on a common value, we start a consensus algorithm to decide on a value. There's usually a leader process that takes care of making the final decision based on the vote it has received from its peers. We send messages on a channel, channels get congested, there's too much traffic, we get bottlenecks, and so on. We end up with network partitions, unresponsive computer, is the computer dead? This is all metaphorical language, and there are more metaphors there that I don't want to bore you with. So yeah, when we don't know how to explain something, we use metaphorical language all the time. And yes, it is time that we don't talk anymore about master-slave. Take it out. It's very, very easy. Anyway, let's talk about buzzwords. And you know this one, right? Containers. I was wondering why containers picked up so much. But if we think about containers, like the actual physical container, it's a standard thing that can be shipped anywhere, fits on trains, ships, and trucks. You can stack them, you can reuse them, and so on. It's a very good language to speak about this thing I'm trying to build, and I'm trying to sell you. I also wonder if at some point somebody will be having a startup to recover wreckage from shipping containers. I don't know. But another buzzword is microservices. When I read this blog post, they say decentralized governance, monolith versus microservice, isolation, collaboration, small is better, big is cumbersome, David versus Goliath, whatever. When I read the whole blog post and say, but this is Erlang. Second paragraph, this is Erlang. Next paragraph, this is Erlang. I don't know if any of you here works in Erlang. But I was like, wow, these guys literally stole everything from Erlang and gave them a new name. In the very last paragraph on the footnote, it says, in another direction, one could argue that microservices are the same thing as the Erlang programming model, but applied to an enterprise application context. So are you crying, little Erlang boy, because they don't use Erlang? No, I'm not crying. My question is, what is Erlang elevator's pitch? These are the metaphors in Erlang. Kill children. You spawn children. You have supervisor on those children. And the actor model, what is even the actor model? So imagine trying to sell Erlang with this kind of vocabulary. Very hard. So first, get people to understand things. Then explain how things actually work. For example, is RabbitMQ a job server? I was a RabbitMQ core developer, also developer advocate. When people ask me this question, I will say, no, it isn't. RabbitMQ is a queue server. A message is much a higher abstraction than jobs. You can also do jobs. And like, oh, OK, dude, shut up. It is a job server, yes. Understand Rabbit with that metaphor, and then we can go deeper and try to see what it actually is. Conclusion. We need to master the art of metaphor selection. We need to master the art of meaning amplification. And finally, our program is a metaphor for the solution we found. If you want references, some of the books I read, some of the pictures I stole from the internet, and thank you very much. Yes? One more thing, I want to say thanks to the organizers, because it's not often that you see a conference where Latinos are not only serving food, Latinos are speaking, Latinos are there in the crowd, so thanks.